First of all, a big thank you to Autodesk for inviting us to show you some of the things that we've been doing in BIM over the past 4 or 5 years. Just a brief background, I'm a mechanical engineer with too many years of experience to let you know, but that includes 32 years working in the Gulf, and Manish, this is Manish and I'm Barry, if there's any confusion. Yeah. Manish is an architect who's been working on BIM probably for 15 20 years. Yeah. In Dubai, we work under the Dubai Consultants brand. We're part of their office here, and we work with them, and we've been working with them now for 2 months. ThinkBIM works in India, and ThinkBIM is a practice we founded in India, and we've been working there for 4 years now, developing skills on BIM to meet what we thought was going to be a growing demand. And a lot of our clients are contractors, because it seems to be the contractors the ones who have seen the value. That's changing now with mandates to design in BIM from various governments, including the UAE, Singapore, UK, etc. But there is a desperate shortage, I think, of qualified BIM engineers. There are lots of people who can model, but taking it beyond the modelling stage to actually engineer your systems in BIM, so you get the full benefit of the tool. We're going to first of all just highlight why we need to change and some of the efficiencies you can get, and then we're going to show you some practical examples that we've got from working with contractors. The efficiencies don't just happen in construction, they start at the design stage. And the more you're clear at the start of a design on a project, what you want to get out of it, the more benefits you can get from BIM, and the more cost effective it is. So there's a number of headings on the slides here, and we'll take you through those one by one.
Yeah, but I'll quickly summarize to begin with so that it remains in the mind. So, ladies and gentlemen, today we'll show you and demonstrate with examples of successful case studies which we've recently done to achieve efficiency using BIM, whether it's time, cost, or overall quality improvement. We're going to see what is the difference between traditional and optimized process using BIM, which is integrated project delivery, reduction in MEP over design using BIM, reduction in work stages. There are different work stages in a typical concept to commissioning of a life cycle of an asset. We show you how using BIM via IPD we've reduced significantly the time and the cost over the project. We'll show you how accurate costing in real time can be derived from BIM, which enables you to take better judgments. We will also show you energy efficiency gains which could be done on BIM. We'll show examples of BIM-based value engineering, which shows cost benefits. We will show you how prefabrication and standardization was deployed in BIM environment and then fabricated offsite. We'll show you automated offsite fabrication from model and how the construction happened in MEP environment, and then eventually the summary of benefits. So I'll let Barry take you through the background.
Okay, we heard 2 of the speakers this morning talking about disruptive technology, and I was one of the people who was disrupted on my drawing board when AutoCAD came in, and it set the industry back quite a while, because the issue when anybody who's drawn on a drawing board with ink on tracing paper would know if you make a mistake, to correct it was very difficult, because you had to scratch the ink out with a razor blade, you had to get an eraser to smooth the tracing paper over, you had to make sure it was completely dust free and dry, then you could re-ink over it. So the draftsmen in that era were brought up to actually look at what they did very carefully and not make a mistake, because if you made a mistake, it could set you back 2 or 3 hours to correct a very small mistake. When we changed to AutoCAD, we found that people could put lines in, do things very quickly, and because they could undo it, change it, delete, they didn't really pay as much attention to the detail. And for many years, it cost the industry a lot of money because of mistakes that were made on drawings. I've been in the industry 47 years, and I've got to say I've seen no improvement from the day I first started to today in efficiencies. There's very few people have improved the way they do things and the way they construct things effectively and consistently. And studies in the US, for example, show that there's been no improvement in construction productivity in 60 years. And that's quite staggering when you look at what manufacturing has done. And I was talking to somebody who worked in the Toyota factory, and he told me when he joined the factory about 5 years ago, the average shelf life for a spare part was something like, I think it was 3 weeks. It's now 6 minutes. They've improved the productivity so much that nothing is sat on the shelf waiting. And I think we're a long, long way in the construction industry from achieving that sort of efficiency. However, what I think we can do is if we look at the IPD as a management system and BIM as a delivery tool, we can improve not only the way we design things, but the way the contracts can build it, because there will be less issues on site and people can actually see what's going to be built before it's built. I also think that BIM or Revit as a design tool is a big improvement from the change from manual drafting to AutoCAD, because when you go from AutoCAD to Revit, you actually see in 3 dimensions what you're drawing. So it's less likely that you're going to make a mistake, and it's more likely you're going to check what you've drawn before you issue it or send it to somebody else. We are traditionally MEP consultants, and we introduced BIM into our design process for a number of reasons. It's quite staggering when you, and this is not just in the UAE, be it UK, Australia, where I've been working in my career, there's gross over design on the MEP systems. And it all starts with the air conditioning. And CIBSE, the UK institute, did a research paper in, when was it, I think it was about 1990, that showed that just about every building they looked at was grossly over-designed, with excess margins from 30% typically up to 84%. When you take that step further and you look at when the peak design in a building actually occurs, it's only for 0.1% of the year. So why put excess margins on your cooling plant, which then increases your electrical load for such a small time in the year? Also, some studies done in thermal analysis and dynamic CFD analysis of buildings has shown that you can reduce the capacity of your chiller plant by 20% with almost no reduction in comfort conditions. So the concept of adding margins on margins to give yourself a safety factor actually works against you, because you also have problems controlling temperatures if the plant is grossly oversized. And I do a lot of hotel work, and the majority of work and problems I come across is over design. And when you go when you're staying in the hotel room at the time when you need comfort most, in the evening when you're trying to sleep, it can't maintain it, because the system, and I've come across systems, fan coil units, up to 50 times the capacity they should be. So the unit comes on, it overcools the room very quickly, then it switches off. So the idea behind getting the system capacity correct is not just to save money on the capacity of the plant and the systems, but it's also to make sure people are comfortable. And BIM as a tool enables you to do that very early on in a project. This example here just showed one project we analysed where the system was actually 65% over capacity, and we could reduce it by 35% capacity very easily. There would have been no effect on the comfort conditions at all. Managed? So first of all, what is the impact of the construction costs on the life cycle of a building? And this is a typical life cycle cost of a building where the design cost is about 3% of the total cost. The build cost is 17%. The actual majority of the cost comes during the working life of the building, which is about 80%. So for the cost, spending a little bit more money during the design period you can save substantial amounts of money during the life cycle of the building. And we're going to show you a very simple example of a building we did. We analysed at concept stage from an existing concept and revised it to generate some savings in capacity and running costs.
So, as Barry was mentioning, in the last 50 years, we haven't seen any productivity in construction sector, and we personally believe we've tried it and we've seen it happening, that integrated project delivery and approach, which is based on BIM, helps you do that. This graph which you are seeing, I'm sure a lot of you would have already seen, but in case you haven't, I'll quickly tell you the background of this. This graph essentially shows the ability of a designer or an engineer to influence the project in terms of cost is high in the beginning. In the left side, if you see, is the concept stage, and as you move towards the right, you see the other stages of design, development, construction, documentation, and construction going on. So it shows that in the early phases of the project, you make a decision, you can control the cost of the project easily. As you move forward in the project, however bigger the decision or change you make, the impact of cost is felt right away, and you cannot do much about that. So using this principle of shifting the decisions or having the data to make decisions from a stage which is somewhere around construction documentation to taking it a bit early towards where scheme design and design development is happening, you can incredibly change the fate of the project, the outcomes of the project, and have a better control. So this hump, black hump, has to move towards left, which means people have to engage early, information has to come in early. We will demonstrate in a couple of next slides how this theory was actually implied on a project and how we've changed the stages and gained about 40% reduction in the time of construction from concept. Also, before we see that, it's important for us to understand that when we get into an integrated project delivery environment, there is an impact. The impact is a difference in various factors, not only technology, which we're talking around BIM, but other areas around entire delivery engine which change. So I'll quickly list those so that we keep this in background, and then as we go in the presentation, you'll see how this IPD is deployed and then individual examples of benefits. So with the traditional project delivery versus integrated project delivery, the biggest difference will come in the way the teams work or how the teams are. It will have an effect on the process in the entire concept to commissioning development exercise. It will have impact on the way risk is shared in the project. It will have an impact on compensation and reward. It has an impact on communication and technology. It has an impact on the way agreements in the project are set up. Which means, for example, in a traditional environment, teams were fragmented typically, but here in integrated project delivery, they will be all integrated as one team early in the project. In terms of process, while the process in traditional manner is linear, one sequence outcome becomes the input for the other sequence, and that's the way things follow. While in integrated project delivery environment, using BIM as a tool, you work in a concurrent environment. Information gets exchanged between various disciplines, between various softwares, and you are able to analyze quickly. Risk is individually managed in traditional environment, while in IPD, it is collectively managed. In terms of compensation and reward, again, individually directed in traditional manner. Here, the team success is tied up to the value-based system. Coming to communication and technology, which we have seen significantly, from a 2D paper-based drawing, we move into a 3D, moving into 4D, adding time and 5D as cost as dimensions into it. And finally, the agreements, instead of transferring risk from one person to other in a traditional environment, which means concept would be done in a certain way, passing it on to design development stage, which will pass on to contractor, contractor will pass on to subcontractor, and finally, you try to make decisions in the end. In IPD environment, it is open, collaborative, and risks are often shared with the people. Putting this perspective in background, so is important to get the full benefit of IPD on BIM. Now we'll show you very quickly in a way how a traditional process is worked around. In a pre-construction phase, typically you will have a concept from a designer, which will then move into a single line diagram, which would then move into a double line diagram or a drawing, which will be in a design development stage, which will then move into a double line diagram again as a tender drawing, which again gets developed into a drawing, which is GFC, which then comes to a contractor for actually making a shop drawing on top of that, which then is taken on site, execution is started, clashes are found, queries are raised, engineering is done on site, solutions are made there, decisions are done there, and then you finally build something which you record in a drawing. This involves essentially at least 6 to 7 times drawing production again and again, and information starting from a point, reaching to a destination, starting again, reaching to a destination, which is a big waste. In an IPD environment, we did this in one of the projects where we brought the contractor early on board, brought different stakeholders early on board, and see how the project changed significantly in a BIM environment. In this IPD BIM environment, you take concept and schematic in the model in level of detail stages called 100 and 200. I'm sure most of you would be aware about LOD levels, so I won't go into detail, but it's about the level of detail you build in the 3D object and the level of information you put in the 3D object as the project progresses forward. So here you build the model, you get initial scheme, and rather than quickly starting producing drawings, you start looking at it from an independent perspective of value engineering. You start looking at what can be value engineered, saved, and you will see examples which Barry will show you live after this slide, where we've done that and we've gained significant benefits. So you do a value engineering, you do a user requirement exercise, and then arrive at something which is more optimal. This is the stage where you engage a contractor in as well. You set out 2 things at this stage. You do a zoning strategy and you do a prefabrication strategy in line with the contractor's capability, requirement, and availability of equipment or the infrastructure. Once this is done, you start making your model, which is moving into design development stage, which is LOD 300 or 350. You start putting more information. Apart from initial geometry and the roots, you start putting in actual data which can be analyzed, different properties, details, which gives you approximately 80% of cost certainty as the data which comes out of the model can be accurate. This exercise, when you do in the model, keeps enriching. It involves all the stakeholders coming together, reviewing, removing clashes, analyzing, reanalyzing, and then eventually you come to a point where you declare a design freeze, which you have a position where you have a near 100% cost certainty. This then you can take to LOD 400, where you start doing support details, minute conduit details and stuff like that, and get a fully done shop drawing out of it. This shop drawing can be fed into a CNC machine, which we will show you how we have done it. And from there you get these individual prefabricated units done off-site, brought to site, assembled with a minimal amount of labor and expertise needed, which then moves into a final construction, which you get back into the model. By this way, you've done only drawing production 2 times. You've reduced your 7 to 8 stages to about 2. And in future, we clearly see that after the stage of LOD 300, you can actually tender with the model if you want a different contractor to come in. And with that, there will be much higher accuracy for the other contractor to look at as well. This has given a reduction of 40% time from concept to the time we were on site. We'll again summarize this example in this slide, where instead of having the construction's consultant's tender drawing, which is on the left, we pick up a single line diagram from an engineer who would have done a scheme, take it into the model, coordinate, and get a shop drawing out of it, which can be fed. This is for a live project we did recently in India, a residential, and we could get saving of 40% in timelines. There's another example of a project we did in Afghanistan from client based out of Dubai, where you see from model we've generated the shop drawings, accurate quantities, and seamless transition from concept to production. Now we'll get into the benefits around different other aspects using BIM, which I'll let Barry explain.
When you start a design, the architect would typically come up with a massing model for the form of the building. And this illustration here is showing 3 different massing models for a building having the same area. So the first thing to establish is which one is aesthetically pleasing for the client, which is the most appropriate. But then there is a big impact on both energy and daylight on these different models. And I don't know if any of you would like to have a guess of which is the least energy using building.
Any guess?
Any guess? Is it number 1, number 2 or number 3? No? Or we'll highlight them. Make a decision yourself and see if you're correct. So the first building typically is about 117 watts per square metre per annum. The middle building is 67 and the end one is 74. So you can see that the form of the middle building would use about half the energy of the form of the other 2 buildings. It also has quite a high daylight efficiency of 90% of days, so it is the most effective. But often it's not the energy efficiency that will drive the building, it's the location, it's the form, it's the views. There's a whole host of things to take into consideration. But by inputting a 3D model into an energy program, very early on in the design process, you can examine all the options and make a decision based on all the facts. And it takes about, from having the model built either in Revit or SketchUp, to actually do the energy analysis takes about 2 hours. To change the data and rerun it takes about 20 seconds. So
because it's on cloud.
Sorry?
Because it's on cloud.
Yeah, I was going to lead on to that. Yeah. When I came into the industry many years ago, I would do a calculation for one room to work out the peak load and the peak temperature, and it would take 1 week. So you didn't do many rooms. You didn't do it for a building. You would do it for one room and try and average it. The tools now are so powerful, and as Manish said, because the server is on the cloud, it can be done very quickly. And you can actually do it in front of the design team if you can get the client, the architect, and you can make a decision on the spot because we can get all the right information. So this is a project where we were involved in, where a contractor was tendering an existing design, which is the one on the left, the current design, and we just modified some of the factors, the glazing coefficient, the U values, and we changed it to a slightly more efficient system. And you can see the table illustrates we cut the cooling load by 1500 kilowatts. So that cut the power demand in this case by something like 350 kilowatts. So 350 kilowatts less of power, 1500 kilowatts less of chiller capacity. The energy use reduced from $9 a square metre to $8 a square metre. Now that on its own doesn't look very significant, but when you run that over a year, if you go to the next slide, Manish, if the building's got typically a 25-year life cycle, it's saving $50 million per year. It's got the wrong units on in currency here.
Half are right, half are wrong. Sorry.
Yeah, it's $51 million that building would save over its 25-year lifetime by making the changes we suggested, which didn't affect the look of the building in any way at all. And it actually also produced something like a $15 million saving in the MEP systems. And all that can be done extremely quickly, very, very quickly, because the tools available are so powerful. This is just a graph showing indicative savings we're getting by doing this task very early on in a project. We get about a 15% saving in the MEP if it's designed reasonably well, at a cost of about 2% of the cost of our fees. So it's a very good investment to pay somebody to do the analysis very early on. This is another building we, again, the same contractor was tendering. There were 2 towers. The image on the left is what the existing design looked like It wasn't designed in BIM. We created a BIM model from the existing consultant's design. Then we redesigned the pipe distribution. We relocated some of the air handling units. We kept the same systems in. And you can see just visually there's a significant reduction in pipe work. We actually took out 4.8 kilometres of pipe work. We reduced the HVAC cost by 30%, electrical 12%, plumbing 40%, fire 25%, DG 5%, and the lifts by 25%. The lift cost was reduced because we were also able to reduce the floor-to-floor height, and the plant was all placed on the roof over 2 levels. Because we modelled it in BIM and we were able to move it about and check the access, we managed to get all the plant on 1 level. So not only did we have the savings of, well, significantly high, I think it worked out about 25% on the overall MEP, we had a saving in the building by reducing floor-to-floor height and taking a floor off the building. And BIM as a tool gives you the facility to do that very, very quickly. Another area we look at, and again the benefits from working with a contractor, is in prefabrication. In India, it's very hard to get skilled labour. In other parts of the world, it's getting harder to get skilled labour, and it's very hard also to get skilled supervision. So the contractor we're working for has set up a prefabrication yard, and the aim is that he can build a lot of the work off-site with a lot less labour, 1 supervisor. It can be shipped to site, and it actually saves a lot of time and labour on site. Site becomes less cluttered, easier to work on, and the whole process becomes quicker and more efficient. This is a simple example of a sprinkler range pipe. This was the basement on this building is 3 million square feet.
About 3 million square feet.
About 3 million square feet. And we took a simple zone of sprinklers, and the design, as it was designed previously, is on the top. We redesigned it, different distribution, and we cut the sprinkler cost for each module by 50%. Not much over a single zone, but when you multiply it out over 3 million square metres worth of area, it's enormous.
Yeah. And the reason we could do that was when you have everything done in BIM, you could do questioning in the data. So for example, in such details you won't go if you're working in a traditional environment. We just kind of tried finding out how many fittings get reduced if we change a standard length to something else. And then you just do this permutation combination, and you find out suddenly that half of the fittings are gone. And that could be a huge saving. So
the next one is a riser, and this was for a hotel in Mumbai which had 8 towers, each 100 metres high. So there was a significant amount of these risers, one between every 2 guest rooms, over 8 towers, 100 metres, something like 10 per tower, so it was significant. The existing design had been done in 2D. So first thing we did was create a 3D design in Revit. When we created the design, it became clear to us that we could change the layout of the various pipes and ducts within the riser and still maintain adequate clearances. The contractor wanted us to use circular ductwork. It's very rare you can use circular ductwork because the risers are typically sized for wide and narrow ducts. So if you're trying to do this exercise on a 2D drawing, it would be almost impossible. So by creating a 3D BIM model, we managed to accommodate circular ducts.
Which are cheaper.
Which are more efficient, less cost, less joints, easier to make. Then we were able to move various pipes within the riser and optimise the pipe length, so we were using standard lengths of pipe with no offcuts, and we saved something like 2 kilometres of pipe work just in doing that. We saved a massive amount of time in construction because it could all be constructed off-site. On this particular site, there was a beam that ran right through the middle of the riser, which is shown on here. So we had 2 options. One where we had a sacrificial formwork system built into the riser so that it could be installed before the slab was cast. The second one, it was just installed in a frame that could be dropped through the penetration if the slabs were being cast above it. The contractor then built the riser, delivered two to one site, brought the client along to see it, and connected them together. And the connection time was something like 4 minutes.
I think we have a video for that.
We'll show you a quick video now.
Yeah. Which will show exactly the whole process which we said from beginning, reducing the steps and getting our fabrication done.
And what this illustrates is we saw some examples earlier where whole buildings were modularized off-site and construction time was extremely quick. You can't always do that in a lot of buildings because there's not enough modularization. But there are always areas within the building that you can do this, and it can save you lots of time and money. So this is the module that has the sacrificial formwork in it. So this could be constructed before the slabs were cast, and I think they could go something like 4 levels above where the slabs were cast before they started having support problems. All the connections were quick fit, either flanged or coupling fittings for pipes, and spigot and socket connections for the ducts. In this model, the fire rating for the walls was all installed before it was delivered to site. So everything was checked, quality controlled in a factory environment. So there was no damage done, and when it's delivered to site, you can lock it up. And anybody who's been involved in large construction sites knows what happens when services are exposed, particularly in riser cupboards. They get damaged by other trades. This prevents that happening. And the plan is to build the whole range of risers with probably 4 craft tradesmen and 1 supervisor. It says our installation time reduced from days to minutes, and you can see as the pipes and ducts connect, everything fitted perfectly. And again, a benefit of BIM was getting the dimensional requirements very accurate and being able to build it to those. This is a second option that could be installed after the slabs have been cast. It's just connected on a supporting frame and drop through the penetration. So there are options of doing it either way, either before the construction or after the construction. Okay, that's just a summary of the advantages which we've highlighted as we've gone through. So we talked about efficiencies in design, in eliminating the number of drawings we produced. Again, this is an actual example from the same project where we did a 3D coordinated model in Revit. We generated the shop drawings from that coordinated model. The contractor used the Revit drawings to input into his CNC ductwork fabrication machine. He had staff who had got 3 days experience, 3 days training, and the output was a very, very tidy ductwork bend.
And none of these staff was ever working on a site or a fabrication environment yet. Because the machine reads the model, you just have to hold, rest of the things are done by the sequencing machines itself. So that improves your quality, reduces your time, and gets your labor cost down as well.
But it also improves your construction time because there's no need to do a fabrication drawing from the workshop drawing, which is traditionally used for manufacturing ductwork as an example. The shop drawing goes straight into the sheet metal cutting machine and it's produced. So that project is now going ahead at quite a fast rate.
Yeah. And this is the example which we saw earlier of how to deploy IPD environment omitting so many stages, and actually in this project it was done from a scheme design, value engineering done, construction engineering in the model itself, shop drawing, and straight into the construction site. It dramatically reduced time, and in fact gave developer options to analyze while this was going on.
The next area we've used Revit MEP is a pet project of mine. I've been trying to improve the way projects can be commissioned for nearly the whole of the 47 years I've been involved in the industry, because on every project, the balancing of the chill water system, balancing the air systems, it never gets done. They try and rush it at the last minute so that ceilings that are closed off get opened up again, so somebody goes up with tools to measure air flows, water flows, damage gets created. So we were experimenting early in the year to see if we could use Revit MEP as a tool to virtually commission a project. We started off with this very simple example, which was a chiller with 4 air handling units, and what the output we can get from the Revit MEP program is the excess pressure at each commissioning valve. So normally in a project, you only do the pressure of the index circuit, and you don't know what the excess pressure is anywhere in the system. So traditionally, when you go to commission a system, you find out which is the index circuit, which is the one with the highest pressure, the one with the least pressure, and then you have to go to every other valve in the project, and if it's a 300-bed hotel, it might have 1,000 valves. So it takes a lot of time and a lot of hours to do that. With this program, we get the excess pressure at each valve. We can then select a commissioning valve and select a setting on the commissioning valve to take out the amount of excess pressure that we have. So that means, in theory, we can pre-commission the whole of the system before it's constructed. In reality, there will probably be some tolerances and some things that don't quite meet. But we're doing one of the projects with a contractor we're working with, where we're going to do this as preset all the valves, and he will check them. So when his commissioning engineer goes on site, he will go around and check every valve. In theory, they should all be giving us the right flow. In practice, things happen on site that throw things out. So we're expecting some slight difference. But even if it's a 5 to 10% difference, it's probably 80% better than things are at the moment. The next stage we're doing with this, if you just jump on, Manish.
That's the next one.
Oh, it's on already, okay. Is we reduce the size of the pipe to the first air handling unit, because that was the unit with the lowest pressure drop. And straight away, all of the excess pressure we had on the previous design have more or less evened out. We've only got 0.4 of a foot, 0.8 of a foot, and 0.5 feet excess pressure. So what we're looking at now is a program we can integrate to optimize the pipe sizing, to minimize the commissioning requirement, and then we'll only put commissioning valves in where they're 100% necessary. So that will not only save cost of putting the valves in, but a huge amount of money in commissioning. And hopefully next year we'll have a result and tell you if it was successful or not. Back to you, Manish, to summarise.
So I think, just to kind of summarize again what we saw, the benefits right from the concept stage. You could optimize design, you could do the clash detection, you could do real-time analysis, change sizes. You could actually, you saw the shortening of life cycle time, which was reduction of stages, reduction of number of drawings. You could do BIM-based construction engineering, which meant more than what you had done in the early scheme stage. You could look at individual products, individual materials, and then accordingly start saving money. You could produce your shop drawing straight out of the model, which can then lead to standardization, prefabrication, and while this all was happening, it was an efficient change management exercise. Whenever there was a change needed, you do in the model, everything gets updated all across. So there's a single source of truth. We were also consistently been able to see the cost of the project coming out of the model in real time, which helped us keep our target in check. And we're still working on this project to the next phase where you take the same benefits to facility management stage. We haven't got the analyzed benefit percentages yet, but I'll quickly show you the glimpse of what we are doing there. We're picking up the design data and carrying forward it to a stage where you could have a ready electronic document management system. You can link it to the facility management software to save on the cost. Some of the things we're doing with the same project with the contractor is, and we will quantify that and probably next time we can share, is we're optimizing the downtime area of crane because we have this entire model linked to the schedule. And when you compare the two, you can see at what point of time which crane during construction will not be operating if this schedule has been adhered to. So then you can tweak your schedule and start looking at how you can reduce probably in the whole construction period one entire crane, and that reduces your cost. You can analyze existing facilities. We've in the same project used it to analyze the cut and fill levels and optimized cost for that. We've also done a full visualization of schedule. That video is not working, which was attached here actually right now, which connects your entire model to a Primavera or a MS project program and lets you visualize how the project is going to build, broken down into labor, cost, and material. So at any point of time, you can look at your system and say, this point of time, my project should be built of approximately 30%, and my labor cost and material should have been spent this much %. And you can keep verifying that and start looking at options. We haven't done yet. The last step in here is linking it to the procurement system of the contractor, which we will do this year, and see how we can order the material right from the model specification, which is highly detailed into 400, and connect to the supplier's database as well. The FM piece, which I was explaining, is around using the design information at the time of design in the element itself, in the model, carrying forward to the stage where your facility management software would actually apply. So the whole idea of BIM is about information. Graphics is what you see, but underneath the graphic is a set of fields which you can control on. So for the moment, we've picked up about 10 or 15 different fields, which we from beginning capture during design stage, take on as a separate data, which can talk to any other system, and then combines with a facility management system. So you, in the end of the project, by default, have a ready operation and maintenance manual coming out of the project because your data is lying in the Revit system. And then you also have this connection in the handover, which can link to any facility management software. So we use this with a software called eDocuments, which is a UK-based software, and we in joint partnership work on that.
And as anybody knows who's involved in the construction industry, getting the as-built drawings is difficult enough, but getting the right as-built drawings is almost impossible. In linking it to the BIM model and inputting the information from the equipment as it's purchased, the documents are automatically put together for the equipment that you're using. And then the correct maintenance schedules are brought into that program. And you can read the model, you can click on any item of plant or equipment and straight away get a status. You can generate reports at any stage to understand where the O&M manuals are. And from a contractor's point of view, it's nearly always the thing he's least interested in because his efforts go into finishing the project. This work can be done very early on, and it means there's very little to do at the end of the project.
Also, one of the things which we are analyzing when we are taking this data to facility management, operation maintenance stages, if you are an owner and you have different assets, it's very difficult to do analysis of your entire asset, how to optimize cost during your OPEX. But when you have this data of every project coming in, and we've started doing for 2 of them, and once it becomes more, we'll assess, you can quickly see which is the most bought out pump in your company. For example, just look at search in there and it'll say, this pump has been bought these many times, or which are the most standard products you've been buying across the different projects, which are the equipments which have similar specification but you've bought different. So you can analyze your program level requirements and then say why we are doing so many different procurement. We may standardize this and have a supply chain done in the manner where you again optimized on your negotiation with the supply chain. So those are the kind of things you play with the data when you have it. with you. This is just listing of all the fields which you can keep populating in, which could be simple as specification to location of floor, to area code, to the supplier, to the expiry date, to the maintenance date, to warranty, to legal documents, everything you can link in there. And because we are working in a BIM environment from beginning, we don't have to, in the end, get this information by putting somebody and spending that effort and time, which is difficult. To get a as-built and operation maintenance manuals are very difficult and they consume a lot of energy. This by default comes as an output because we have been working in a seamless process using BIM as an enabler. I think, and just to tell about our...
Yeah, this is just showing you some of the projects we're working on from New York across to Australia. So we do work across the world. We are located here in Dubai and located in India. And if anybody has any questions or wants to speak to us about what we're doing after, we'll be around for all the day.
And once again, in Dubai, we operate as Dubai Consultant.
Yeah.
That's what we are here as.
Okay, thanks very much, everyone.
Thank you.